Hi everybody. Today I wanted to look at our power supply a bit further. I wanted to show you the raw power board, look at a couple of design aspects there, look at some bulk capacitance, take us through some design decisions, and yeah, just show you guys the board so far. First of 3 boards so far that we need to look at, and let's get cracking. So one of the first things we need to do is to calculate how much capacitance we actually need. We need this board to push at least 3 volt at 3 amp max ratings, and to do that we obviously have to calculate the capacitance correctly. So let's look at a quick way of how we would go ahead and calculate the actual capacitance required for this board. We work out the bulk capacitance required for our first stage of our power supply. So the formula for that is V ripple, and equal that to current, so the maximum current you'd like to deliver, divide that by 2 times the frequency times your capacitance. So why 2 times? Because we use a full wave rectifier. In my case, the power supply should output 30 volt at a maximum of 3 amps, right? So how much is a good amount of ripple? So so what I would do, what I was thinking of using a 36 volt power supply for that core, and the center tap on that will be 18 volt. So let's see how that works, right? So effectively I have, let's say, 6 volt that I could play with in terms of ripple and all of that. So as long as it doesn't fall below 30 volt at any point, we should be good to go. So let's work this out. So if we have a maximum of 3 amp, divide that by 2 times 50 times, let's say, 10,000 microfarad of capacitance, right? So that would be, let's complete the formula, 3 times 100 times, and we move the little comma 6 times that way for micro, and that turns out to be 0.01 farad, right? These guys cancel each other out, so that gives us 3/1, or equal to 3 volt ripple. So what we can see here is that 3 volt is more than enough for a 36 volt power supply. So let's just work it out a little bit further. So if you have 36 volt coming in, we have to subtract 2 times 0.7 volt for our bridge rectifier, right? And that ends up being 36 minus 1.4, which is equal to 33.6, right? If we further make sure that we still have enough bulk capacitance for our, we still need to factor into that our minimum dropout voltage of our LT3080, which is around, the LT3080 has a dropout voltage of, I think, from memory, about 330 millivolt. So that's well within spec, right? So we have about 3.6 volt still available there from that. Sorry, so we have to, is that right? 4, sorry. 4.6, sorry, math failing me there for a moment. So if we then subtract the other 3 volt that our ripple is going down to, we end up with 31.6 volt, right? So minus our 0.3 volt there, let's call it 0.4 volt, and we end up with 31.2 volt, right? So we have about 1.2 volts spare there to play with in terms of our ripple and our dropout, etc. So that should work out quite fine. So now that we've calculated that we need at least 10,000 microfarads of capacitance, and we know that that'll be within our ripple current will be sufficiently low, etc. Let's have a look at how we would lay this board out, because obviously 10,000 microfarad is quite a bit, and there's a couple of ways to do this. You can put this all into one big capacitor and bolt a couple of leads to it, or you can spread this over a couple of capacitors. Dave Jones from the EEVblog recently published a video, quite a good video, where he went through that, explaining why you want multiple, why you would parallel up capacitors, and that's exactly the process that I've used. So let's have a quick look at what I've done so far. So what I've had a look at is to put a whole lot of capacitors in parallel for each of the two sections. Remember, I have that should actually be a 30 volt version and an 15 volt version. So those two labels are wrong. But how I got to those is, let's have a look at digit key quickly. If I search for capacitor, right, let's go for these aluminium caps because they work quite well for bulk capacitance. So now the key aspect now that I have is not so much the values of these capacitors, but the size, right? So I'd like to keep these things in 3 distinct layers so that they don't poke out on the side like you saw in the first video I showed you guys. I quite like everything to be fully contained. So let's say if we take a seated height, right? So I doubt that we're going to get anything in below, let's say about 7 millimeters. And I don't want this thing to go above 20 mil. So if I have to put 2 standoffs on top of each other, that's about the maximum I'd like to go. I'm not going to bother setting up all the others. What I do also want to do is I want to keep the diameter to less than about 13 millimeters, because I noticed that's quite a convenient size. So let's just pick all the round ones. I don't want the ones lying flat on the board, and let's just pick all of them that is roughly smaller than 13 mil. And the other important thing I wanted to do is to set the voltage, right? Because you get some low voltage caps that are really small, but those obviously won't work for us. So I want to run, let's say at least 35, let's say up to about 63 volt. So those are the parameters I'm going to set, and I'm going to apply that filter. So we're going down from about 9,200, or well, it might result in, if the filter is already applied. Yep, so we still have about 9,200 capacitors to choose from. What I like to do now is to actually see the maximum capacitance we can fit into that space. So I'm going to order by capacitance. Okay. Right. Oh, sorry, I did it the wrong way around. Order by capacitance. Right, and we see that we can actually fit 1,000 microfarad into one of those caps, right? And we see, because I'm going to be running, alright, so hold on, before we get there, if we have a look at this, the size we've got here is, yeah, that's a 13 mil by 20. And we've got, so what I also like to do next is to, let's limit those capacitance. So if we run down there, we can see some surface mounts coming in at about 680, probably 560. I wouldn't go lower than 560. So let's apply a couple more filters. So let's say our capacitance should be between yeah, 500, one of those three, right? And we apply those. And now we have 85 capacitors to choose from, which is quite a bit better than what we had. So what I generally like to do now, because I'm not going to run very high volumes, I mean I'm planning to build this thing for myself, so it's again not designed for manufacture, not designed for bulk manufacture. I'll go and order the unit price from low to high, right? What we then have a look at is, right, so there's a little capacitor, bulk capacitor, 680 microfarad, but at 680 you'll see it uses up our full size available on the board. If we go down, sorry, if we scroll down, let's have a look at one of these guys. There's a 1000 microfarad cap, and he is, right, so there's a 1000 mic that also fits into the same size. Now at 30 cents per unit, that's quite a nice option. However, let's look, there's the catch. You need to buy 700 of these. So if you just scroll down to the one-off items, so there we have an example. So there's a, let's see what this one is. That's 680. There's a 1000 microfarad cap again at 64 cents each, and it fits into our maximum size we've set. If you scroll down a little bit, here we have a 680. You have to buy 200 of those. Let's see where the first surface mount single item is. So there we are, and that's about 560k, right? So 560 mic. Looking over to the side, we see that these quite a bit lower, and it fits into a smaller package as well. So based on those two, those are the two options, right? So if you wanted this thing really, really low down, you can probably find some shortish standoffs. There's another option. Let's look at this one, 680 mic. It gets a bit lower. So there's a couple of options. There's a point I'm trying to make. So, and these also vary by availability and what's your budget and what your constraints are. So what I've decided to do with the board was to actually overlay quite a few capacitors on here. And the reason I've done that is if you look at the circuit board layout, I've actually put two sets of capacitors on here, right? And you'll see that if I flow the board, they all connect, and they're all well, theoretically, if you were able to place two things in the same space at the same time, you could put all these caps on here. But the idea, let me show you what the idea was. So let's say we make our copper, our PC board, and there you can see the silk screen shows two types of capacitors kind of overlaid with each other. But the idea here was to allow for some flexibility when we come to actually buying the components and assembling the board. In the first instance, you could use those little surface mount caps and fill this board with loads of capacitors, and you'll see, because we have the two sections here. There you can see the break in the capacitor. So everything on this side of the board is for the 30 volt rail, and all of this is for the 15 volt rail. The other option, if you use the other layouts, you could end up, if you use the bigger caps, as you see there, I can put two standoffs on top of each other, and we could use the bigger radial caps. So those also quite fine. However, I've put quite a bit more capacitance on each board than I actually need, just to fill up the available space. Because obviously the more capacitance you have on the input phase, the better, because that just stabilizes your power supply a little more against transients and those kind of things. It spreads the load, the heat being generated off these, etc. So in reality, if we went for the smaller caps, that's if you go for 560 microfarads each, that's sort of the minimum amount you can put onto the board to still maintain the 3 volt ripple. and there you can see we've left some open. Similarly with if you use the 1000 microfarad ones, you use a couple less. It's the minimum required to fill up the board. So there you can pretty much see the design decisions I've gone through, why I've chosen those, why I've laid it out like this. You've seen that I kept the standoff posts in the same place. Just to go through that again one more time. Let's go for that view. Over there we we'll actually crimp and bolt the transformer leads coming in there. These standoffs, these 3 standoffs in the back, should be metal standoffs, and they will actually electrically connect the lower board with the upper board, the second phase of the power supply. And these guys are obviously in the same slots where the Arduino fits onto the top board. So I've just taken those all the way through just for some decent rigid mounting. And yeah, in the bottom, these will also be plastic, of course, so that we don't short everything out to our case, and standard plastic ones down the bottom. That's the thought pattern so far, and I think, I don't think that's bad. I'm obviously not. This is the first variable power supply that I've built down to this detail. I wanted to build something decent that I can actually use in the lab. It's nice and stable. But that's the thought pattern so far. Hopefully next time we'll get to one of the other phases. And then shortly after we need to start shipping these things off to get manufactured and buying some parts. And we'll see how this project progresses. So this is where we've gotten so far. If you guys enjoy the project, please let me know. Give it a thumbs up. Tell your friends, tell your family. And let me know if you guys have any better ideas, better thoughts. But that's the idea so far. And let's go with that and see where we get. Thanks, guys.